Hello everyone. Today I'll be presenting about interacting with Openstack, your best private cloud platform that does exist in RIT and that you all can access it and have your own virtualized environment. So let's jump right in. Before we start, okay, who am I? If we have not met yet, my name is Malik. My name is Abdul Malik, but I go by Malik. I'm the ops lead, senior BSMS, interested in home labbing, DevSec, blah blah blah, etc. And let's just go to the topic. Uh, Anthony asked me to not rush, so I'm not rushing. All right, understanding OpenStack. So what is OpenStack? Does anyone wanna help me defining what is OpenStack? Even if you want to make a wild guess, that's fine. I just want to hear what you thought on OpenStack. Pin in your head. Any other ones? No? Okay. So, what is OpenStack? OpenStack is a set of software tools for building and managing cloud computing platforms for public and private cloud. That's a really huge definition. What does that exactly mean? We all know Google Cloud Platform. We know from Brad's presentation about AWS, Amazon Web Services, and all of those fancy names that keep appearing as cloud computing company and whatnot. OpenStack is something similar to those, but it can be deployed for your own private like environment. So meaning you have the physical servers, you have the physical storage, you have the physical rack, and you have the physical networking, but you cannot virtualize anything on them yet. So OpenStack, you can deploy it on that server, and it will give you the virtualization environment. To make it in a simple word, imagine the VMware workstation that you all have in your laptop. It enables you to launch VMs and interact with the UVMs in an isolated environment as you want. And that is OpenStack, but in a larger scale. Another good example of that, you all participated in RISEC last weekend. I think it was last weekend, right? Yeah. I guess. Last weekend, you offered an RISEC. Where did that environment come from? There was like 15 teams, so many machines, and whatnot. Any laptop would not be able to run that. So we host that in our virtualized environment, which is OpenStack. So, how do we deploy OpenStack? I will not spend so much time because it's not the scope of this presentation, but I will just give you a way that we deploy OpenStack. OpenStack is Dockerized. OpenStack now, every service has many core services and every service is Dockerized. And to deploy all of those OpenStack software, you need to actually deploy those Docker containers. And for that, there is something called Cola Ansible, which is automate the deployment process of OpenStack. You have your inventory file, you define all of your hosts, your servers, your IPs, any like password, keys, whatever details that you want to give you OpenStack deployment, and then just like sudo cola ansible deploy, and we'll just go and do the process for you. So that is cola ansible. Now let's have a closer look on OpenStack core services. Caution, there's light mode coming, but it's not dark mode, so it's fine. All right, so this is not a fully comprehensive list, or maybe it is. I'm not sure. It's really outdated, kind of. So it might be missing some of stuff. And as I mentioned, all of those, every name that you see is a different service, and each server mostly has its own Docker containers. So if you want to run a specific service, you have to deploy or specify that in your deployment config file that okay, I need the Horizon service, I need the OpenStack client, I need the Nova client, I need the Swift, I need the Ionic, I need Cyborg, whatever service that you wanted to deploy, it should be defined in your config file. So there is a lot of like OpenStack backends for compute, for storage, for networking, for hardware, for shared services, and some for like client tools like CLIs, and some for integration, and some for operation and tooling. And there's a lot of that list goes on. But when you see this graph the first time I saw it last year ish, I really got scared. So I said like, wow, we need to manage all of those. This is like really scary because I have no idea up to now what all of these does and what they all mean. So that is the OpenStack core services. Again, OpenStack has a lot, and it's going into like being a headache. So let's focus on the core service that we actually interact with. From that huge image, now we have this few softwares that we can always use, which fulfill our use case. So whenever you go to stack.ritstack.cloud, you'll be seeing a GUI, and that GUI is hosted by something called Horizon, which is one of the OpenStack core services. And then there's Nova, which is the compute engine or the compute mind of your server. So whenever you have a virtualized machine that is running on Nova service, and that is actually the RAM and the CPU of your VM can be like replicated from that service. Glance is used to store images. Swift is just to build templated VMs or like templated deployments. Neutron is the network manager. Cinder is the block storage for that. Heat is also another templated deployment. Centimeter is for monitoring, and Keystone is for your user experience, for like same as your AD environment, but it is in OpenStack. So I don't expect you to know all of those, but those common names, if you wish to be more familiar with OpenStack, you should at least know what those name means. Again, Nova for your compute, Glass for images, Neutron for network, Cinder for storage, for block storage, Heat for templated deployment, Centimeter for monitoring, and Keystone for users and authentication process. Nova, the primary computing engine behind OpenStack, it's used for deploying and managing large numbers of virtual machines and other instances to handle computing tasks. Neutron provides the networking capability of OpenStack. It helps to ensure that each component of OpenStack deployment can communicate with one another and quickly and effectively. So Neutron is the wizard of OpenStack that runs in the back end and try to make sure you can connect that connects it back to you, and everyone is can see each other, and everyone has connectivity to the internet to and to themselves. Glance provide the image service to OpenStack. In this case, image refers to virtual copies of hard disk, and Glass allows these images to be used as template when deploying new virtual machines. For simplicity, we can consider images as ISO file. Whenever you're trying to boot up a new VM, you have to give an ISO file that has the operating system in it, and that is what is called image in OpenStack. Cinder is block storage component where your data access speed is the most important. Why is that? Whenever you have a laptop, you have a hard disk in that, and whenever you have that in a virtualized environment, there is not actually a hard disk, but there is service that support as a hard disk to a storage server. So that is Cinder. Cinder is like store the actual data or the actual hard disk of that VM, and make sure that you have accessibility to all of your files, configs, whatnot of those like aspects. Keystone provide identity service for OpenStack. It is essentially a central list of all of user of OpenStack cloud mapped against all of the services provided by cloud, which they have permission to use. So it's like your AD environment. You have a user, you have permissions, you have rules against that, where they can go, where they cannot go, and how they can access, and who has to have like a password, or who now must use like a key, and all of those fancy stuff can be managed through Keystone. Horizon is again the OpenStack GUI, the front end that you all see whenever you go to stack.rt.cloud, and that is Horizon. Uh, yeah, as we mentioned, OpenStack service deployment, Colonel Answer will deploy these services. We can customize those services to exactly what we need. We don't have to deploy all of those OpenStack core services in the white picture that we just saw. But if you want a specific services that is fit your need and fit your use case, you can just select those and disable the others and just deploy your OpenStack client. There are many other services offered by OpenStack and the community. It's constantly under like development. So if you wondering about something like new about Kubernetes, they have a service now for Kubernetes, and there's a lot of stuff that can be deployed as a service for OpenStack. For simplicity, let's say an image is equal an ISO file. As I mentioned again, whenever you're trying to boot a VM, you have to give it an ISO file, and that ISO file can be referred as an image in OpenStack. So whenever you hear someone like, oh yeah, let's just change the image, or let's get a new image, or get me that image, that mean they are referring to an ISO file that can boot from the virtual machine. And for our own clusters, it is like about RIT6. We have multiple images, and this is not the comprehensive list, but we can, if you go to Openstack and just like see the images, you have different OSs. So as you can see, we have Ubuntu 18.04, Focal Force, Desktop, Debian, FreeBSD, some Windows, or whatever like service or whatever OS you want. Possibly would be there, and if it's not, we can work together to get it uploaded there. Again, as you all saw, RSA was mainly or like primarily run on OpenStack, and everything was hosted by us. So any VM that you saw during that competition, that means we have the image for it, which is the OS for it. So let's now talk about cloud config. Cloud config is was like a kind of new topic introduced to me during the summer. I have no clue what was that, but after like some debugging and some help, I was able to figure it out. So what is config? For Linux, cloud config is for Linux, and we will talk about a different service for Windows. It's mainly written in YAML, and it can take Bash or Python. Cloud init is the industry standard for multi-distribution methods for cross-platform cloud instance initialization. During boot, cloud init identify the cloud is running on and initialize the system accordingly. Beside that, Cloud Init will just be able to identify the environment, install all the drivers needed, and everything in that aspect. But TLDR for us, for our use case, we can give it a specific YAML config file that can customize the machine as it boots for us. So, for example, I want to create a user, I want to change a password, I want to add SSH keys, and all of those cool stuff that you can do. You can give it a YAML file, and that would do the trick for you. As we can see here, some examples. The first one on the, I don't know, your left, maybe. You can see just like a simple script, a cloud config script that can just change your password. And in the one below, you can see something a little bit fancier to uh, create a user, disable the password, and add SSH keys for me. And it's not here, but that's what like our standard script that we usually use for ops. And you can see some other script that create a user, add SSH keys, and create different groups, add it to the group, change the shell, and change the password, and SSH password authentication enabled, and all of those time zones set. And if you just like Google Cloud Config examples, you can see a lot of customization that you can do. For simplicity, let's assume Cloud-based is an equivalent of Cloud Config, but for Windows, and it mainly take PowerShell scripts. So since it mainly take PowerShell scripts, so if you want to create like a user on your Windows deployment, you can just create something as net user Malik and give it a password and give like the login password and change no active yes, and add is just like add the user, and slash y whenever like it says like Windows you have something like interactive, but since it's during the boot process you cannot interact with the VM, so you have to give it the full command that will bypass any user interaction. And then we can give just like add it to a local group. We can add myself Malik to the administrator user group, and just like maybe change the user administrator's password as well, and just have our system configured as we want. There is a lot of functionality that you can do. For example, for cloud config for Linux, you can install packages. You can make some changes to the operating system as you want. You can customize it in many ways as much as you can, but as advanced you go, the complex it will be. So now we talked quite a lot. Let's see a quick demo. So first of all, if you all need access to OpenStack, where shall you go?
Your home address.
No, not my DMs. When you need stack access, you go to help the RIT the cloud and submit a ticket.
So people make those?
Yes, it's a thing. It is a thing. So if you need stack access, you wanna, for example, I wanna just create an environment to play with teleport. It was so cool, but I cannot afford to run it on my host or my laptop 24/7. I need something stable and always running. So just tag access request and deploy teleport for you. Just experiment stuff and have teleport up and running. It's so cool. So you can access your stuff. So as soon as you have your account, when you log in, there's a default project for you where you can see some status overview of your own project. You can see how many instances you have, how many virtual CPUs, how many RAM is allocated for you, volumes, floating IP, which is equivalent of public IPs, and all of those fancy stuff. But let's not focus on all of the details and let's focus on what cares or what matters for you. So whenever you on OpenStack, you are there for one reason. You want to deploy an instance. I want to interact with something. So let's just go ahead and do that. When we just go there, you click on compute in your project, click on instance, and then launch instance, and just give it a name. So let's give it a name of it's gonna be hot demo. Okay, yeah, it's gonna be hot because I'm writing it on one hand, but it's fine. Demo. So now we just like initialize the VM name. We wanted to call it demo, and now it just asks me to give it a source, give it an image file, give it an OS so it can boot from. So I'm just gonna select I wanna an Ubuntu. So let's just create a quick one. Ubuntu Focal Force 2004. We just selected the image. Now it is selected for us. Now there is something called flavor. What does flavor mean? Flavor is something whenever you create a VM, it asks you, okay, how many hard disks do you want to allocate for that? How many RAM do you want to allocate for that? How many CPUs do you want to give that? So this is like the equivalent of flavors in OpenStack. And here we have few predefined flavors that you can actually use and select. So for example, for this deployment, it's gonna be not really intensive and I'm probably gonna delete it afterwards. So I'm just gonna make it Linux tiny, which give me two virtual CPUs, 4 gig of RAM, 20 gigabyte of storage, and that's all I need for this demo. Then we're gonna go into networks. The default networks, whenever VM created, it will create in a shared network with everyone, which is about like ClubNet. It's named ClubNet. You don't need to change that unless you want to do something specific for your own local network and you want to create your own private network. And for that, you can also submit a ticket to get help with that. Network port is whenever you're in cloud computing, as Brad mentioned last time during his cloud computing security presentation, he mentioned that every instance or every VM or whatever service that you are running is supposed to have its own like private IP or its own public private IP. It's like something allocated for that instance, so that can be the standard of cloud computing. So if you have a specific IP that you want to give, you will create a port on your own network and you will assign that port to your own instance. So you will be sure 100% of the time that your machine will have this IP address. But for this case, we just choose the network. So we just gonna give it, all right, go to the network, ask for DHCP and get any IP because I didn't care enough about you. Security groups is the firewall of like your instance itself. So if I want to allow SSH, I want to deny FTP, I want to enable HTTP traffic that comes to my traffic, to my VM, that would we want to do it. You can also have this, and you can also have IP tables or whatever firewall service that you are using, but it is the equivalent of that, but an OpenStack level itself. So the Neutron, the network manager for OpenStack will control the traffic that goes to your instance because you have defined security groups. Key pairs, if you don't have SSH keys and you want to create an SSH keys, OpenStack will help you with that and will create you one of those keys. Configuration. As we mentioned, all of those images on OpenStack does not have a standard user, or it does have a standard user, but does not have a password set. So whenever you create a VM, you will have to give it a config file, which is a cloud config that will initialize the password for your VM. So for this, I have few examples that will be published soon after this talk, and this will be if Notion wanna run, please. Not this Notion, please. Please. Okay, here you go. So we have I have few examples here that add switch keys and set password. So for this first demo, we're just gonna do and just do cloud config and change the password. If you want to change the password, you can do it anything here. And for simplicity users' sakes, I'm just gonna make it Malik and the password. So I'm just gonna copy paste this file in, And after that, our machine is ready to go, and we can just click launch instance, and we can see, yeah. Um, no, okay, please. As you can see now, your instance in OpenStack is actually getting deployed. It got an IP address, it got the flavor. You can see how many virtual CPU you have, how many RAM, size, etc. And what's the availability zone. That's a later topic. Maybe I will do a part two of this where we go advanced in OpenStack. So you have your instance now in here. If you just click on it, I open a different tab. You can see some more information that you have in here. You have like the ID, how long it's been up, when it was created, and you can see some action logs to map the user to what they did and how they did it and everything. So when you click on the instance itself, the one thing that you are interested in is console. So you just click on console and click on show only console, and that will just forward you to the VM itself. So as I mentioned, most of the VMs or most of the flavors, most of the images that we have a standard username, but does not have a standard password. So you will always have to set the password yourself. For this Ubuntu deployment, the standard user is Ubuntu. If I can type, please. Yes, Ubuntu, and the password we just set that to be Malik. As you can see now, you have access to your own virtual Ubuntu server that you can run teleport on, for example, or whatever service that you want to run. I want to run a website. I want to practice for my blue teaming stuff. I can just have my stuff. I have my boxes, and I just go figure out what does a service run, how does a service run, how does that be configured, how can I know that I'm on the right track of defending my stuff. So that is the first demo. Anthony, do we have time for another one? No? All right. So that is like how you deploy OpenStack in like your own environment. So again, if you need access to OpenStack, helpdesk.ritset.cloud, submit a ticket, and then you can have your own virtualized environment to play with and just use for fun, or school projects, or any project that you want. But yeah, that I think will conclude my presentation. Yeah, thank you, and here are some of the resources. It's not like other people might do. Yes, uh,
What is your favorite flavor?
peach. No, no, my favorite is Linux X large. Oh, so good.
Um, no, you don't know. So when you were doing all those, like the Nova and everything in the beginning, are those like independent solutions that Ansible uses, or are they made for Ansible?
Those are made for OpenStack, and we use Ansible to deploy those.
Yeah,
Yeah. Perfect. Any other questions? For a team, you can have your own environment to test your tools on before they break the actual infrastructure for the competition.
Yeah. You can also have those like red team info.
Yeah,
Supposedly.
yeah.
Supposedly.
And all right, thank you so much, everyone, and see you whenever I see you.
Bye, Malik. Bye, Malik. Bye, Malik. Malik's going to. Everyone clap for Malik.